We are back with video number 2 on inverse trig functions. We got cut off on the first video, so I'm not really sure what I said that you heard and what you didn't hear. So let's recap. We've drawn the inverse of y equals cos x, and it's not a function because it obviously fails the vertical line test. Its equation can be written as x equals cos y, because we just switch the variables x and y in the equation when we get the inverse. This is not a function. It's not a function because it is one-to-many. It's a one-to-many non-function. But that's kind of strange, folks, because on your calculator and on my calculator, there's clearly an inverse cosine button here. So let me just show, for example, I'll type in 0.5, which we know we should be able to do. And if I press second cos, sorry, I have to do the other order, second cos 0.5, and I press enter, my calculator is programmed to only give me one value, not many values. So have a look at that graph over there. Which value did it give me? Of all of the possible values that run up and down above the number 0.5, which of these values did it give me? Question mark, question mark, question mark, question mark. Which one did we get? The first positive one is the one we got, yeah. So let's highlight the one that we got. So we ended up getting this one. It's a bit hard to read the scale because the vertical scale is written as in terms of pi over 2. But we know that pi over 2 is about 1.57. I'll just mark that as 1.57 here, approximately. So this value here apparently is 1.05 approximately. It's strange then, or is it, that the calculator is programmed to give you only one value? But I'd like you to think about it. If you were designing a calculator, would you design a calculator that if the person enters something, it would give them an infinite number of answers on the screen? Or would you design a calculator that only gives one value?
One value.
Yeah, you'd have to do one value. It's not practical to write all of the infinite possible of numbers on the screen. That's silly. So let's talk about, if you look at that inverse cosine function, it goes on forever. I'll highlight in yellow that it goes on forever here. Of all of that, what part of the graph would you keep and program into your calculator, and what part would you not keep in your calculator? So have a think about that. Obviously, where we have the yellow dot shaded is going to be in the part that we keep. Let me rephrase the question, because only one hand went up in the class. So only one person had an idea what I was talking about. Okay, so what we have to do is we have to cut away parts of this graph and throw them away, and only keep a piece that will be a function. We have to get rid of the fact that it wavers up and down forever and is a non-function. So we have to keep a piece that's a function and throw away everything else. What would you choose? If you got to choose, what would you choose to keep? Jack?
X between negative 1 and 1 and y positive.
Y positive forever?
No, positive to pi.
So you're saying, okay, so you're saying this piece here.
Yeah.
Okay. Are there other choices you could make?
Yeah.
Well, no, because that's like the positive is easiest to use.
I don't know if you folks can hear that. So Sahil has said there's really no other good choices because this one seems to be the best one. But I think implicit in what you said is a recognition that there are other chunks we could have kept. Like, let me draw one for you in blue. We could have kept this one.